All right, so we're going to jump into section 1.3, and the title is Factoring Trinomials of the Form x squared plus bx plus c, which may not mean a lot if you don't really read mathematics so well, but trinomial, since we're factoring again, and all the problems in this section are trinomials, which means the problems have three terms. So every problem that we're going to factor in this section will have three terms. And the key thing that makes this section different than the next section is there isn't a number in front of the x squared term, or there's a 1 in front of the squared x squared term. So I'm factoring problems that have three terms with a 1 in front of the first term. When we get to section 1.4, we're going to be factoring trinomials with a number other than 1 in front of the first term. They're a little bit harder. And for both sections, 1.3 and sections 1.4, there's at least two ways to do every problem. And I'll show two ways. I probably might know 3 or 4 ways to do some of the problems, but I'll show two ways, and likely the second of the ways I show you'll probably like better, and you're only responsible when it comes to the test to be able to use one of the two methods in each section. And so I'll start off doing the method that I think is slower and maybe not the method that most students will pick to do these problems, factoring trinomials with either a 1 or not a 1 in front of the first term. And then I'll show the way that most students will wind up using. So the instructions for 1 through 28 ask me to take the problem that starts off with 3 terms and rewrite it with 4 terms, and then that will make the problem factorable by grouping if I rewrite it with 4 terms properly. And then I'll factor like we did in section 1.2, and I'll check my answer. So there's a strategy for this, and at first probably it's best to factor using a table. And my table is going to be fairly consistent. The first column in my table are going to contain the factors of the last number. In this case it's 6. So my first column of my table, I'm going to put the factors of 6, which are 1 and 6, and 2 and 3. Those are the only pairs of integers that I can think to multiply to be 6. And in this section, to go from a problem that has 3 terms to rewrite it with a problem that has 4 terms, we're going to change the middle terms. So I'm going to say ways in my middle column to rewrite 7x. And the ways I can rewrite 7x are 1x plus 6x, which is the same as 6x plus 1x. There wouldn't be, those are considered the same because addition is commutative. And the other way to rewrite 7x that might make sense in this problem is 2x plus 3x. And then I'm going to combine the middle column, or the terms in the middle column. 1x plus 6x is 7x. 2x plus 3x is 5x. It's supposed to be obvious, but it may not yet because this is the first problem, that I'm going to rewrite the 7x as 1x plus 6x, because that kind of fits the problem. The numbers that I put in front of the x's multiply to be the last number, and the numbers I put in front of the x's add to give me the middle term. So I made my table, I looked at the last number, found factors of it, attached the letter x and put a plus sign between the factors, and then I added them, and I found the pair that gave me the number that's already in the problem, the 7x. So I'm going to rewrite this problem with 4 terms. I'm going to go x squared plus 1x plus 6x plus 6. I wouldn't have been any different in terms of my final answer if I had put 6x plus 1x. That would be equally okay. So it would have been okay on this step if you wrote x squared plus 6x plus 1x plus 6. You'll get the same 2 factors in your answer. Your parentheses will be in a different order from mine, but it's still going to be correct. So now I'm going to factor by grouping, which we just did in the last section. So I'm going to go x squared plus 1x in a parentheses, put my plus sign, and 6x plus 6 in a parentheses, and this does equal the line above it. First parentheses, I factor out a common factor of an x. When I factor out an x, I take 1x away from those 2 x's, I'm left with 1x. When I take the x away from the 1x, I'm left with a 1. Bring down this plus sign. Second pairing, there's a common factor of a 6. I'll divide each of the numbers by 6. When I divide that 6 by 6, I get a 1. I'm left with the x. Bring down this plus sign. When I divide that 6 by 6, I'm left with a 1. Now there's a common factor of x plus 1. I'm going to factor it out. And I'm going to write x plus 1. And then what's left first is an x. What's left second is a plus 6. Again, if you did it this way, you would have gotten x plus 6 times x plus 1. And that's completely okay. When I factor a trinomial, which parentheses comes first and which parentheses comes second is not important. Just as long as the contents of the parentheses are correct, you can switch the parentheses orders. I'm done with this problem, but I'll check just to get going today. Anytime I factor a trinomial, I can check my answer by foiling. So I'm going to FOIL my answer to make sure it equals the original problem. If I FOIL my answer and it doesn't equal the original problem, then I've made a mistake. So I'm going to check by going firsts, which are x times x, that's here, which is x squared. Outers are x times 6, which is a plus 6x. Inners are 1 times x, which is a plus 1x. Lasts are 1 times 6, which is a plus 6. And now I'm going to combine the 6x plus 1x. The x squared I'm going to bring down. The 6x plus 1x I'm going to add as a plus, make them a plus 7x, and I bring the plus 6 down. Because this and this are exactly the same, then I know I've factored properly. So every problem between 1 and 28, I'm essentially going to do this. So I'll move down to number 4. And number 4 is going to be harder because it has a negative sign. But I can do the same table approach. So I'm going to write one column for the factors of the last number. The last number in this problem is 6. And then I'm going to write ways to rewrite negative 7x. Signs are hugely important in this problem. And then combining the terms in my middle column. So when I go to fill out my first column, the numbers I put in my first column have to specifically multiply out to be positive 6 because that's the last number in the problem. And unfortunately, I have to get more creative because if I just picked those, I'd say I can rewrite this as 1x plus 6x, or I can rewrite this as 2x plus 3x. That's more or less what I did in the last table. I took the factors of 6 and made a 1 and a 6 and a 2 and a 3. The 1x plus 6x gave me 7x. The 2x plus 3x gave me 5x. Neither of these pair are the way that I need to rewrite the problem because when I combine these, I don't get negative 7x. This means I don't have all the factors of 6 written down, and generally I like to avoid factors with negatives in them, but I can't here. The factors that I'm missing of positive 6 are negative 1 times negative 6, because negative 1 times negative 6 multiplies to be positive 6. And I'm also missing negative 2 times negative 3. So when there's negatives in the problem, then all of a sudden you're going to have factors with negatives. Factors with only positive aren't going to help. So another way to combine the negative 7x, I'm just going to write this as negative 1x minus 6x and negative 2x minus 3x. When I combine these, both the numbers in front of the x's are negative, so I'll add them and keep them negative. Similarly, these, both the numbers in front of the x's are negative, so I'm going to add them and keep them negative. So it turns out that this pair, or this column, is the important column. And what I'm going to do is I'm going to rewrite the problem by changing the negative 7x to negative 1x minus 6x. So I'm going to change the problem to x squared minus 1x minus 6x plus 6. If I simplified this line and I combine the kind of outers and inners here in some sense, you'd get that minus 7x. So that's actually good. I've rewritten to something that's equal to the original problem, and the something that I've rewritten will make it so factoring by grouping works. So I'm going to factor by grouping now. I'm going to capture the x squared minus 1x in a parentheses, and I'm going to capture the negative 6x plus 6 in a parentheses. The first term, I'm going to factor out a common factor of an x. I'll take 1x away from the 2x, be left with 1x. I'll take an x away from the minus 1x, be left with a minus 1. In the second parentheses, I have to factor out a negative because the first number is negative and the common factor of 6. So I'm going to put a negative 6. And then to figure out what's left, for the negative 6x, you go negative 6x divided by the negative 6 that I factored out. And the negatives cancel, the negative 6's cancel, I'm left with a positive x. And then for the positive 6, when I factor out a negative 6, I divide positive 6 by negative 6, and that will give me a negative 1. Again, I generally can factor out a negative without having to show the division, but just in case you didn't know how to do that. Now I'm about ready to write my answer. I'm going to factor out the x minus 1. When I do that, I'm left with an x and a minus 6. I claim that's my answer, which means I should be able to check it by foiling. So I'm going to check to make sure my answer, when I FOIL it, simplifies to the original problem, because that's the only way an answer is correct. If when you multiply it out, you get the original problem. So I'm going to do firsts in my checking, which are x times x, which is x squared. Outers in my checking, which is x times minus 6, which is a minus 6x. Inners in my checking are minus 1 times x, which is a minus 1x. Lasts in my checking, minus 1 times minus 6. The two negatives multiply to be a positive, and I get a positive 6. The outers and the inners combine. Because the numbers have the same signs, I add them and keep them negative. So I'm going to get x squared minus 7x plus 6, which is identical to the original problem, so I know this thing that I said as an answer is correct. Problems are a lot easier when they don't have negatives, and that's the case in number 6. So I'm going to make my table for number 6. My first column are going to be the factors of the last number, in this case the number that's written dead last is a 4. And the factors of 4 that I know, 1 times 4 is 4, and 2 times 2 is 4. Those are the only factors of 4 that I know. I want to rewrite this 4y, so I'm going to say what are the ways I can rewrite the 4y. Based on the numbers I have here, would be 1y plus 4y, or 2y plus 2y. And I'm going to add these numbers up or combine these numbers. I'll just write combine, I guess. The middle column. 1y plus 4y is 5y. 2y plus 2y is 4y. When I factor, whether I'm grouping or using the strategy that we're going to learn at the second half of this section, I don't make this table. I can look at the numbers and I can figure out how to split them up in my head without actually making the table. But some students need to see it, and that's why I'm showing it. But you don't have to make a table. If you can know how to break up this 4y properly, then you can avoid this step. So I'm going to break it up into 2y plus 2y because those add up to 4y. And I'm going to say, I'm going to go y squared plus 2y plus 2y plus 4. I just took that 4y and separated it into 2y plus 2y. Again, if you combined this line, it would equal the line above it. Now I'm going to factor by grouping. So I'm going to put the y squared plus 2y in a parentheses, and then the plus sign doesn't need to go in the parentheses like the minus sign did. First parentheses is a common factor of a y. When I factor out a y, I'm left with a y plus 2. Second parentheses is a common factor of a 2. When I factor out a 2, I'm left with a y plus 2. So now I'm going to get to my answer by factoring out the common factor of y plus 2. And that leaves me with a y plus 2. It would be okay to write that, say that's my answer. It would be better to write 1y plus 2 with an exponent of 2, because anytime you're multiplying two identical factors, that can be written shorthand with an exponent of 2. So either for number 6, y plus 2 times y plus 2, or y plus 2 quantity squared. And if I want to check this, I'd probably FOIL this, because that's easier to FOIL for me. So I'm going to check by FOILing. My firsts are y times y, which is y squared. My outers are y times 2, which is a positive 2y. My inners are 2 times y, which is another positive 2y. My lasts are 2 times 2, which is a plus 4. I'm going to combine the outers and the inners and leave the rest of it the same and get y squared plus 4y plus 4, because that's exactly the same as the original problem. I know that both of these things that I said our answers are correct, because if I was simplifying y plus 2 quantity squared, the first thing I would do is write it without the exponent, and then I would FOIL it. So the problems with only pluses I think are a lot easier. The problems with minuses, I have to introduce minuses into my factors, and that's the case with number 8. I have a problem with a minus. When I have a problem with a minus, when I go to make my table, I have to introduce minuses, and the double pluses won't work. So I'm not going to do the double positive factors here. In my first column, I'm going to write numbers that multiply out to be 4 with negative signs. So negative 1 times negative 4 multiplies to be a positive 4, and negative 2 times negative 2 multiplies to be a positive 4. I could put 1 and 4 and 2 and 2, the double positives, but there's no chance in those helping me out, so I'm not going to, because I know that I somehow need to get a negative into the problem, and if I only have factors with positives, it's just not going to work. So I can rewrite the negative 4y as negative 1y minus 4y, or negative 2y minus 2y. Because the numbers in front of the y's have the same signs, when I combine them and I add the numbers and keep them negative, the top one would combine to be a negative 5y, the bottom one would combine to be a negative 4y. This must be the right pair, so I'm going to rewrite the problem as y squared minus 2y minus 2y plus 4. And again, that would simplify to be exactly the line above it. And this is going to make grouping work. So now I'm going to do my grouping. I'm going to make a y squared minus 2y and a minus 2y plus 4 parentheses. First parentheses is a common factor of a y. When I factor out that y, I'm left with a y minus 2. Second parentheses, I'm going to factor out a negative 2. And to figure out what's left, I'd go negative 2y divided by negative 2. The negative 2's cancel, and you're left with a positive y. And then the 4 in that parentheses, when I factor out a -2, if you go 4 divided by -2, you get a -2. It has to be the case that the parentheses are identical. If the parentheses aren't identical, then you've messed up. So now I'm going to factor out the common factor of y minus 2. And then I'm left with another y minus 2, a y first and a minus 2 second. So my answer can be written as y minus 2 times y minus 2, but it would be better to write it as y minus 2 quantity squared. If I check every problem, it's going to double the length of the video, so I'll start checking selected problems. I won't check that one. But it would check if I FOILed out y minus 2 times y minus 2, I'd get that. The thing about factoring that gets it to be a little bit crazy is you have to know your factors of, sometimes larger numbers. And if you're going to struggle with factoring, it's just because you don't know your times tables well enough. And 36 is a number that has a lot of factors. So I'm going to write down all the factors of 36. Quite honestly, if I can know the pair that I need from this column, I don't need to write them all down, but just so you can see. 36 is 1 times 36. It's 2 times 18. It's 3 times 12. It's 4 times 9. And it's 6 times 6. This is kind of a Math 082 skill, but it's a skill that a lot of students don't have. If you aren't good at getting factors, then you won't get real comfortable factoring until you're able to look at a number and you're able to list down all its factors. If you want to stop by my office, I can try to give you some strategies to help you pick out all the factors of a number. And if I do that here, it's going to get kind of ridiculously long, and so I won't. And again, what I'm doing here is a bit overkill. I don't do these tables when I factor by myself, because I can just look at the problem and know the pair that I need without making a full-out table. It turns out that only one pair can ever work. You can't get multiple pairs working. So in this particular problem, I needed to rewrite the 15z, and the way that I'm going to rewrite the 15z is 3z plus 12z. I could have written 12z plus 3z. So now I'm going to rewrite this problem as z squared plus 3z plus 12z plus 36. And notice I didn't even fill in the rest of the right column because I knew the pair that was going to work. The rest of them wouldn't work because this one was going to give me a 37z, this one was going to give me a 20z, this one was going to give me a 13z, and this one's going to give me a 12z, and I needed the pair that gave me the 15z. I'm going to factor by grouping and go z squared plus 3z plus 12z plus 36. First pair, there's a common factor of a z. When I factor out the z, I take 1z away from the z squared, I'm left with a z. I take 1z away from the 3z, I'm left with a plus 3. I know the second parentheses has to be z plus 3, so when I factor out the common factor of a 12, I can cheat and say, well, for grouping to work, this has to be a z plus 3, and just gamble. If I did this step correctly, split the 15z up right, the parentheses are going to match, and so I'm cheating in some sense, or I'm trying to be efficient. Now I'm going to factor out the common factor of z plus 3 and get to my answer. So my answer is going to have one parenthesis with a z plus 3, another parenthesis with a z plus 12, and again, I could always check. Checking is usually foiling. It's optional, but it can't hurt. So I'm going to check by doing firsts, which are z squared, outers are z times 12, which is a plus 12z, inners are 3 times z, which is a plus 3z, and the lasts are 3 times 12, which is a plus 36, The outers and the inners are going to give me that 15z that they need to give me. So when I check this, and again it's completely optional, you should be able to take your answer and FOIL it, and for an answer to be correct it has to equal exactly the original problem, which this does. I know I have to get negatives in my table, so I won't worry about any double positives. So I'm going to write the factors of 36 again, but I'm going to use the double negative factors. So I'm going to go -1 times -36, -2 times -18, -3 times -12, -4 times -9, and -6 times -6. For me, I can already know how to rewrite that minus 15z. The choices would be -1z minus 36z, -2z minus 18z, -3z minus 12z, -4z minus 9z, -6z minus 6z. Now I'm going to combine, and when the numbers in front of the letters have the same signs, you add the numbers and keep the sign negative. So here, these would combine to be a minus 37z. These will combine to be a minus 20z. 3 and 12 is 15. Those will combine to be a minus 15z, which is the pair that I need. I don't need to go any further, but I could have said this is a minus 13z and this is a minus 12z, but I don't need to do that. So for the rewrite, I'm going to go z squared minus 3z minus 12z plus 36. Now factor by grouping. So I'm going to do a z squared minus 3z, get that minus in the parentheses, minus 12z plus 36. Pull out my common factor. First parentheses is a common factor of a z. When I take out 1z from the 2z's, I'm left with 1z. I bring this minus sign. From the 3z, when I take the z away, I'm just left with a 3. Second parentheses has a negative in front of it, so I have to factor out a negative. 12 and 36 are both divisible by 12, so 12 is going to be my common factor. I'm going to cheat again and just write a copy of that parentheses, because it has to be the same for grouping, that the parentheses come out the same. And instead of trying to do the factoring and taking time, if this step is right, then these will be the same. So now I'm going to factor out the z minus 3 that each has in common. I'm left with a z minus 12. I could actually write that. So this should be z minus 3 times z minus 12. Again, I could check this, but I won't check it. So this is the answer to problem 12. (14) is the first one that has a negative number in the last position, and these are a little bit trickier because when I make my first column, I can't use double positives because two positive numbers multiply out to a positive number. Can't use double negatives because two negative numbers multiply out to be a positive number. So I have to put one positive and one negative. So for numbers that multiply to be -6, I could say it's 1 times -6. I could say it's -1 times +6. I could say it's 2 times -3. And I can say it's -2 times +3. Those are the four groups of numbers that when you multiply them, you get a -6 because they all multiply to 6, and if one's positive and one negative, you get a negative when you multiply them. Now I need to rewrite this x. I'm going to say this is a 1x. So I can say it's either going to be 1x minus 6x, minus 1x plus 6x, 2x minus 3x, and minus 2x plus 3x. Now I'm going to combine these. And in this case, when I'm combining, the numbers have opposite signs, so I have to subtract and take the sign of the larger. 1x minus 6x is going to give me a negative 5x. In the second one, the numbers have opposite signs. When the numbers have opposite signs, you subtract and take the sign of the larger. That will give me a positive 5x. 2x minus 3x gives me a negative 1x. And negative 2x plus 3x gives me a positive 1x. That's the rewrite I'm going to use. And when I have my rewrite with one positive and one negative, I always get the positive second because it's going to make it easier on my factoring step. So I'm going to write this now as x squared minus 2x plus 3x plus 3x minus 6. I'm going to factor by grouping. I'm going to go x squared minus 2x plus 3x minus 6. First parentheses, there's a common factor of an x, so I'm going to write x times x minus 2. Second parentheses, there's a common factor of a 3. I'm going to factor out a 3, have to be left with the same parentheses, and it's actually going to work. And now I'm going to factor out the x minus 2 and get x minus 2 times x plus 3. It would be completely okay, not any better or any worse, if you wrote x plus 3 times x minus 2. The order that you write the parentheses in is completely arbitrary. They're both correct. And if I wanted to check this, I can check either version. Since this one's here, I'm going to check this one. And it's optional. Again, that's an answer that works. To check, I need to FOIL. My firsts are x times x, which is x squared. My outers are x times minus 2, which is a minus 2x. My inners are 3 times x, which is a plus 3x. And my lasts are 3 times minus 2, which is a minus 6. These terms combine to be a 1x and a positive 1x. The numbers have different signs, and I'm going to subtract the numbers and take the sign of the larger. And I'm going to get x squared plus 1x minus 6. And that's the same as x squared plus x minus 6 because there's an implied one here. Okay, for 6, my table has to multiply to be negative 6. So I'm going to write in first column of my table, I'm going to write factors of negative 6. I need one positive and one negative again. It's going to be the same. 1 times negative 6, negative 1 times positive 6, 2 times negative 3, and negative 2 times 3. Those are the 4 sets of numbers that multiply to be negative 6. I need to rewrite this negative 1x. There's a 1 that's implied there. One choice would be 1x minus 6x. Another choice would be negative 1x plus 6x. Another choice would be 2x minus 3x. And a last choice would be negative 2x plus 3x. The first pair are going to give me a negative 5x. The second pair are going to give me a positive 5x. The third pair are going to give me a negative 1x. The fourth pair is going to give me a positive 1x. My goal is to get a negative, and it's really a negative 1x. There's an implied 1 there. So I'm going to pick this pair. And I have choices. I could write 2x minus 3x, or I could write negative 3x plus 2x. This is the way I'm going to go. If I have my choice, I don't like to have to factor out a negative, and if I put the negative with the 3x second, then I'd have to factor out a negative. If I put the positive second, I don't have to factor out a negative. It makes my factoring step easier. So there, you can switch the order, and usually switch it to your advantage. So I'm going to make this x squared minus 3x plus 2x minus 6. That would simplify to x squared minus 1x minus 6. First pair, factor out a common, well, factor these now. First pair, common factor of an x. I'm left with an x minus 3. Second pair, common factor of a 2. Leaves me with an x minus 3. Now I'm going to factor out that common factor of x minus 3 and be left with an x plus 2. 18, I need to find the factors of negative 12. So one has to be positive, one has to be negative. I can go 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 2 times 6, 3 times negative 4, and negative 3 times 4, because all 4 of those numbers multiply out to be a negative 12. So my choices on my rewrite, I need to get 1x, would be 1x minus 12x, negative 1x plus 12x, 2x minus 6x, negative 2x plus 6x, 3x minus 4x, and negative 3x plus 4x. I need to combine these, and I'm only worried about the ones that give me the positive 1x. That's the very bottom one. I don't need to combine everything in the middle column. Once I've identified the pair that I need, I can ignore the rest of them. So I'm going to rewrite this problem with a minus 3x and a plus 4x. So I'm going to say this is x squared minus 3x plus 4x minus 12. Now I'm going to factor by grouping. I'm going to make an x squared minus 3x in one parentheses, and then a plus sign, and then a 4x minus 12 in the second parentheses. First parentheses is a common factor of an x. When you factor out an x from the first parentheses, you're left with an x minus 3. Second parentheses is the common factor of a 4. When you factor out a 4, you're left with an x minus 3. Now I'm about ready to write my answer because there's an x minus 3 in common. And when I factor out that x minus 3 that they have in common, I'm left with an x plus 4. And it would be completely okay. It doesn't hardly matter if you switch the orders of the parentheses. They both will check. They're both equivalently correct. There isn't one that's better than another. When you have the same negative 12, we need to start getting more efficient. And when I look at my factors of negative 12, which were these, if I want to combine to get a negative 1x, the bigger of the factors has to have the negative. Probably said that too suddenly. But I'm going to be efficient now. I'm going to start getting more and more efficient. So I know that in general the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. But in this case I'm shooting for a negative 12, so one of these numbers needs to have negative. If the middle term is a negative, then the only hope to get a negative is to take the negative with the bigger of the numbers. Between 1 and 12, the 12 is bigger, it needs the negative. Between 2 and 6, the 6 is bigger. Between 3 and 4, the 4 is bigger. So when instead of writing all 6 factors of negative 12, the other ones that I didn't write, the negative 1 and positive 12, the negative 2 and positive 6, the negative 3 and positive 4, when I combine these, you're going to get positives for the x's, because when you combine these, when the numbers have opposite signs, you subtract and take the sign of the larger. And all of these, we're going to run into a positive rewrite. So I'm ignoring those to save some time. Had I written these, when I combine them, I'd get a positive in front of the x. These are the only ones that are potentially have a negative in front of the x, and I need a negative in front of the x because the bigger number has a negative sign. The top pair would combine to be a minus 11x, the middle a minus 4x, the last a minus 1x, and that's what that is. That's the pair I'm going to use. And again, when I have that flexibility of rewriting, and I have to have signs, this and this still have both a negative 4x and a positive 3x. If I wrote 3x minus 4x, then I'd have to factor out a negative. If I write negative 4x plus 3x, I don't have to factor out a negative. So I'm going to rewrite this going x squared minus 4x plus 3x minus 12. Group it. First ones I get an x squared minus 4x. Second one I get a 3x minus 12. First parentheses, common factor of an x, leaves me with an x minus 4. Second parentheses, common factor of a 3, leaves me with an x minus 4. So my answer is going to have two parentheses. One's going to be an x minus 4. The other is going to be an x plus 3. I'll try to emphasize more about this when you have positive, negative factors, which ones you can throw out and which ones you have to keep as we get through the section, because it's an important distinction. For 22, this is a trick problem. Somewhere at the beginning of this section, it says, state if a polynomial is prime. This is going to be that instance. When I can't find a way to get a rewrite, then the thing doesn't factor. So this one I don't have to worry about negatives. There's no negatives in the problem. So I need the factors of 2. 2 is a prime number, so it only has one pair of factors. And now I need to be able to rewrite the 5x, and I have to combine the numbers in this column. So the only way this tells me to rewrite the 5x is 1x plus 2x. This combines the 3x and not 5x. There aren't any more factors of 2 that can help me. The factors with 2's that have negatives won't make sense in this problem because the problem doesn't have any negatives. So there isn't a pair from the left column that when I rewrite it and combine it, I get the number that I need to. This means this doesn't factor, and we call this prime. If you looked at my answer to this, I would just write prime. Prime meaning it just can't be broken down into two parentheses like the other problems could. Prime are the best ones that take the least amount of work. For problem 24, I also need to rewrite, I need the factors of 2, but I need to introduce some negatives because of the negative in the problem. The only factors, numbers that multiply out to be positive 2 that have negatives are negative 1 and negative 2. My goal is to rewrite the negative 5x. The only choice I have based on the factors of 2 are negative 1x and negative 2x. And when I combine these, I don't get negative 5x. So the only possibility, because of the way when I rewrite the negative 5x, the numbers in front of it have to multiply to positive 2. They also have to get a negative in it. The only way to rewrite the negative 5x based on the 2 doesn't give me a negative 5x. That makes this prime again. For 26, I'm worried about the factors of negative 11. And then I need to rewrite the 2y, and the numbers in the middle column I combine. So if I was clever, I know that I would need, the only factors of 11 are 1 and 11, and I need to attach negative signs to them. The only one that could potentially give me a positive is this one, because the bottom one's going to give me a negative. If I was being clever, I wouldn't even write the second one, because the second one, when I combine it, it can't give me a positive anything. It's going to give me a negative. If I wasn't clever, then I'd write twice the factors that I need to write, but it wouldn't keep me from getting the right answer. It would just slow me down. So the numbers that I put here are the factors of a negative 11, which are those. That would allow me to rewrite the 2y like this. This first rewriting of 2y, the first rewriting would give me a 10y. The second rewriting would give me a negative 10y. Neither one of these give me the 2y, which means there is no way to rewrite the problem into two parentheses. You can't make factoring by grouping work. The whole thing just won't factor. Last one in the first grouping, and then we get to the fun method, or the method that I use. So again, I need to write factors of negative 11, which would be 1 and 11. I need to rewrite, or attempt to rewrite the negative 2y. I'm going to combine. So again, in this case, because I need to get a negative, the negative would have to go with the bigger number. This bottom choice is going to give me a positive something. It can't possibly work. So I can rewrite this as 1y minus 11y, or negative 1y plus 11y. The top one combines to be a minus 10y. The bottom one combines to be a minus 10y, neither of which give me a minus 2y. When I can't get something from this table to give me the number in the middle, we say it's prime. So you don't have to, when you're factoring a trinomial, use grouping. And quite honestly, grouping is a slow method, but it's a slow but accurate method. And it's a slow, accurate method that works whether you have a number in front of the square term or you don't. So it's a good method because it works for every kind of problem, and it's the same for every kind of trinomial. The next method that we're going to use saves a heck of a lot of time, and it's not particularly hard. So I'm going to do a table approach, but I'm going to avoid grouping. So this is the avoiding grouping method. It's real similar. And this is the way most students factor trinomials. They don't group. So I'm still going to make a table, but it's going to be a table without letters in it. Trying to even think what the right thing to write is here. I don't use a table when I factor, so I'm trying to write things up top that will make sense. So just like in grouping, I get the factors of the last. There's no minus sign, so I don't need any minus signs. So I'm going to write 1 and 50, 2 and 25, 5 and 10. I can't think of any more. Now I'm going to write the middle column without the letter. So I can go 1 plus 50, 2 plus 25, 5 plus 10. 1 plus 50 combines to be 51. 2 plus 25 combines to be 27. 5 plus 10 combines to be 15. 15 is the number in the middle. 5 and 10 are important numbers, and they're going to go in the answer. The beautiful thing about this method, I can get to the answer without having to group if I just know what to put first in the parentheses and what to put last in the parentheses. These are going to be the lasts in my parentheses. Firsts are super easy to get because my firsts, I'm going to split the y squared into 2 y's. I'm going to basically divide this exponent by 2, and that tells me my firsts are going to be a couple of y's, and this table tells me my lasts have to be a plus 5, a positive 5, and a positive 10. Because both these numbers are positive, I put plus signs in front of them. I say that's the answer, and let me show you that it checks. To check any foiling, so I should write answer on this. So it's way quicker than grouping, but it's kind of similar in terms of the table. So for checking, I'd go first are y times y, which is y squared. Outers are y times 10, which is 10y. Inners are 5 times y, which is plus 5y. Last are 5 times 10, which is plus 50. And you get y squared. Outers and the inners combine to be 15y plus 50. Because this is exactly the original problem, my answer is right. And I didn't group, and I still got the right answer. I'll do the same thing for 32. I'll avoid grouping and I'll get my answer. I still need to know the factors of the last number. In this case, it's 9. There's no negatives in the problem, so I'm not worried about shoving any negatives in. My choices are 1 and 9, and 3 and 3. I guess I can break up or write them with plus signs. I don't know what the proper name is here. Again, I don't use the table. So 1 and 9 I'm going to write as 1 plus 9 when I break them up, and 3 and 3 I'm going to write as 3 plus 3, and I'm going to get a 6. It's supposed to be obvious what the choice is because I'm trying to get that 6, and that's the pair that gets me that 6. So these guys are going to be my lasts, and they're both positive, so I'll put plus signs in front of them. When I go to write my answer, I need to divide the exponent or split this b squared up into the first. It's first in the original problem. It needs to be split up into the first. I do that by dividing the exponent by 2 and getting b to the firsts. My lasts are a couple of plus 3's. I know they have to be a couple of plus 3's. There's no minuses in this problem, so they must need plus signs. That's the answer. I can completely check this if I want to. And it would be better, again, that's the answer, but it would be better had I written b plus 3 quantity squared. For checking purposes, I would check by foiling. So if I wanted to check, and it's completely optional, I'd go firsts are b times b, which would be b squared. Outers are b times 3, which is 3b. Inners, 3 times b, which is plus 3b. Lasts, 3 times 3, which is plus 9. The outers and the inners combine, and this whole thing simplifies to b squared plus 6b plus 9, which is the original problem, so I know my answer is correct. So each of the problems between 29 and 58, I'm going to make a table and factor without doing grouping. Most students don't need to see this table. They could just look at the problem and know how it factors because they could do this math in their head without writing it down. But I'm going to make the tables just so you can see how they work. For 34, I need to know the factors of 36, and there's no negatives in the problem, so I don't have to worry about negatives. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. That might be enough for you to get the right answer. How about maybe just say lasts rather than break up? I could have positive 1 and positive 36, positive 2 and positive 18, positive 3 and positive 12, positive 4 and positive 9, positive 6 and positive 6. I need to combine these. 1 plus 36 is 37. 2 plus 18 is 20. 3 plus 12 is 15. 4 plus 9 is 13. 6 plus 6 is 12. See the pair that I need. So my lasts are going to be a positive 4 and a positive 9. And my first, I'm going to split the x squared into the first in each parentheses as a couple of x's. So for an answer, didn't really leave myself a big enough parentheses here. So for my answer, I get a couple of x's up first because the x squared is first. You need to split the x's up. And my lasts are 4 and a 9, and they're both positive. And it would be completely okay if you wrote x plus 9 and x plus 4. In problem 36, because the problem has a negative, my factors have to have negatives. They're going to be double negatives to get my 12. So for 36, I need to introduce negatives because the problem has a negative. I'm going to say negative 1 times negative 12 because that multiplies to be 12. Negative 3 times negative 4, and I forgot negative 2 times negative 6. So my lasts could be a minus 1 and a minus 12, a minus 3 and a minus 4, or minus 2 and a minus 6. And now I'm going to combine these. The numbers have the same sign, so you add them and keep them negative. Minus 1 and minus 12 is minus 13. Minus 3 and minus 4 is minus 7. Minus 2 and minus 6 is minus 8. So it must be the case that I need that pair. I'm going to get to my answer without having to do a heck of a lot of work. I'm going to break my z's up as the firsts, and my lasts are going to be a -3 and a -4. It's completely optional, but I certainly can check. To check, I would FOIL. I'd go firsts are z times z, which is z squared. Outers are z times -4, which is -4z. Inners are -3 times z, which is -3z. Lasts are -3 times -4, which is a +12. When the outers and the inners have the same signs, you add the numbers and keep them negative. So this whole thing would give me z squared minus 7z plus 12. So this method of factoring gets to be way quicker than grouping, and more often than not, by the time you get done with this section, you'll be able to go from the problem to the answer without having to make the table, which makes the factoring really fast. The grouping method, even if you don't need the table to figure out how to break up the middle term, you still have to group, and grouping is slower than just writing down an answer. For 38, I need factors of 6, and I need to get negatives in there. So for my table, I'm going to go factors of 6 that have a negative, which are -1 times -6, -2 times -3. My potential lasts, one is a -1, the other is a -6, or a -2 and a -3. And when I go to combine these, -1 and -6 gives me a -7, because they have the same signs. I add them and keep them negative. The -2 and -3 gives me a -5, because again, when the signs are both negative, you add them and keep them negative. So I should be able to get my answer by using the -2 and the -3. I'm going to make two parentheses. I'm going to split the y up as the first, and my last can be a -2 and a -3, and it wouldn't be any better or any worse had you written -3 and -2. So both of those are answers, and they're both correct. For 40, I'm going to write the factors of 11, and I need a negative in there because there's a negative. So the only factors I could pick are -1 times -11, which makes my lasts potentially -1 and -11. I'm going to combine those because the numbers have the same signs. I add them and keep them negative. They combine to be a -12. So -1 and -11 are the appropriate ways to do the lasts. I'm going to make my first a couple of y's, and my lasts are either going to be -1 and -11, or -11 and -1. They both will FOIL out to be the original problem, and they both are correct. (42) and 44, I need a positive and a negative because the last number is negative. So I start off writing down the factors of -8. And the factors of 8 in general are 1 and 8, and 2 and 4. Unfortunately, I have to get one of them positive and one of them negative. And quite honestly, I know which one deserves the negative. When the middle term is positive, the bigger number is positive, the smaller number is negative. So this is the way to go. These two down here, which also multiply to be -8, aren't good, so I should probably write that down. When the middle number is positive, use the factors where the big number is positive and the small number has the negative sign. You definitely could go through and write every pair of numbers that multiply out to -8, but you're doing double the work then. So here, this would give me a -1 and a +8, a -2 and a +4. These I shouldn't consider, but 1 minus 8 and 2 minus 4 are factors of -8, but they're factors I knew I could discount because when I combine these, I want to get a positive number and when the bigger number is negative, when you combine them, you get a negative number. So I know my answer because this is the pair that I need, because that gives me the positive 7. I'm going to split the a's between the two firsts, and then I could either write -1 and +8, or I can write +8 and -1. That kind of doesn't matter. For 44, I need the factors of 24. Kind of get a little crazy there. So my factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I need to have one of the numbers positive and one of the numbers negative, just like in the last problem, because I'm shooting for a positive in the middle. The smaller of the number needs the negative sign. If I wrote the other ones, 1 times -24, 2 times -12, 3 times -8, and 4 times -6, all of those, when you combine them, are going to give you a negative as opposed to a positive. So I'm ignoring those. I'm saving some time. So my choices from our last are -1 and +24, -2 and +12, -3 and +8, -4 and +6. When the lasts have opposite signs, when you combine them, you subtract. So 24 minus 1 is 23, 12 minus 2 is +10, 8 minus 3 is +5, 6 minus 4 is +2. It felt like the 4 and the 6 were going to work, but they don't work because when you have the opposite signs, you're subtracting and you don't get the 10 that you want. So what I'm going to need is the -2 and the +12. So for my answer, I can write a z minus, or a z plus 12 and a z minus 2, or I can write a z minus 2 and a z plus 12. Both of those, if I checked them, would FOIL out to be the original. Since I have a second here, let me just check these. I'll check the bottom one just because it's here. To check, I'd FOIL. I'd go firsts are z times z, which is z squared. Outers are z times 12, which is plus 12z. Inners are -2 times z, which is -2z. Lasts are -2 times 12, which is -24. The outers and the inners are going to combine. 12 minus 2 gives me a 10, so I'll get z squared. Then that's a positive 10z, and then a -24, which is exactly the original problem, so I feel good about my work. 46 and 48 are trickier, but not so bad. So first I'm going to get the factors. I guess they're not trickier, of -10. So I have my choice of 1 and 10, 2 and 5, and again, I can be efficient or I can be inefficient, because each factor you need to throw down a negative sign. Because this is a positive, the bigger number needs to be positive, the smaller number needs to be negative. If you used the negative in front of the 5 or the 10, you wouldn't get a positive, and that wouldn't be good. So my last can be -1 plus 10, -2 plus 5, 1 minus 1 and -10, 2 and -5. I'm going to combine these. -1 and 10 is +9, -2 and 5 is +3. The ones that I shouldn't have written down, 1 minus 10 is -9, 2 minus 5 is -3. I shouldn't have written down because I have no chance to get me a positive. When the middle number is positive and you have to put a negative sign in, you put it with the smaller number. So I can already tell this is going to be the way to go. So my answer is going to be x minus 2 times x plus 5. And again, you could have written just as well x plus 5 times x minus 2. 48, my table, I need the factors of -24, which are 1 and 24, 2 and 12, 3 and 8, 4 and 6. And I don't need every possible factor of -24. I only need the ones that can give me a negative. And in order to get a negative, the negative sign has to go with a bigger number. In order to get a positive, the negative sign has to go with a smaller number. So the numbers that I should choose for my negatives, the place I should put my negative depends on this. This is negative, so the bigger number gets the negative. This is positive, the smaller number gets the negative. So this makes candidates for my lasts of 1 minus 24, 2 and minus 12, 3 and minus 8, 4 and minus 6. Since the numbers have opposite signs, you subtract and take the sign of the larger. 1 minus 24 is negative 23. 2 minus 12 is negative 10. 3 minus 8 is negative 5. 4 minus 6 is negative 2. So I need that pair. I'm ready to write my answer. I'm going to go y plus 2 and y minus 12. But I certainly could have done y minus 12 times y plus 2 would have been equally correct. So if you can get the work done without making a table, it's way better than making a table. And I can look at this and know the answer immediately. But I'm showing the table because some students always need it, and it's completely okay to need it. So my factors of 14 are 1 and 14 and 2 and 7. I'm trying to get a negative 5. Since I'm trying to get a negative number, I'm going to put the negative with the bigger number. If I'm trying to get a positive number, I put the negative with the smaller number. This makes my last potentially 1 minus 14 or 2 minus 7. When the numbers have opposite signs, you subtract and take the sign of the larger. So when I combine the first pair, I get a minus 14. When I combine the second pair, I get a minus 5. So this is the pair that I need. And so I can write my answer relatively quickly as a plus 2 and a minus 7. Again, you can write a minus 7 times a plus 2 just as well. 52, I need factors of negative 20, which are 1 and 20, 2 and 10, 4 and 5. I need to get a negative with one of them because I'm trying to get a negative number. The negative goes with a bigger as opposed to the smaller, which makes my lasts either 1 minus 20, 2 and minus 10, 4 and minus 5. Probably don't even need that middle column. When I combine these, I get minus 19, minus 8, and minus 1, because when the numbers, one positive and one negative, you subtract and take the sign of the larger. So that's the pair that I need. So my answer is going to be x plus 2 and x minus 10. .54, there's no negative, so I don't have to worry about any negatives. I worry about the factors of 5, which are only 1 and 5. My last can only be a positive 1 and a positive 5. Those combine to be 6. They need to combine to be 9. There isn't a pair of factors of 5 that can give me the 9. Makes this whole thing prime. For 56, I need to have factors of 8, and I need numbers to multiply to be a positive 8, and I also need to get some negative signs incorporated, so the only choices are the double negative factors, because double negatives multiply out to be positives. This would allow my last to be negative 1 and negative 8, or negative 2 and negative 4. When I combine these, because they have the same signs, I add them and keep the sign negative. The minus 1 and the minus 8 combines to be a minus 9. The minus 2 and the minus 4 combines to be minus 6. Trying to get minus 3, I can't figure out a way to get minus 3, so this whole thing is considered prime. There's no two parentheses that I could put down that would multiply out to be the original. The last one in this group, I need the factors of minus 11. And again, I could be efficient or I could be inefficient. Turns out when you're dealing with a prime number that hardly matters how efficient you are. But one has to be positive and one has to be negative to get my negative. So my last could be minus 1 and a plus 11, or 1 and a minus 11. Combine these. The minus 1 and 11 is a positive 10. 1 minus 11 is negative 10. I need a negative 2. Don't get a negative 2. This whole thing is prime. The last group of problems, there's a number in front of the first term, or there's not an exponent of 2. And for each of these problems, I have to pull out the GCF first, and then factor what's left in my parentheses. Or I have to factor out a negative first, and then factor what's left in the parentheses. So 60 and 62, there's a negative in front of the first term, and it's way hard to factor when there's a negative in front of the first term. So what I should do is factor out a negative 1, write the opposite in the parentheses, and factor the opposite. And I'm going to do that for both 60 and 62. So for 60, I'm going to factor out a negative 1. And when you factor out a negative 1, you write an opposite in the parentheses. The opposite of negative y squared is positive y squared. The opposite of negative y is positive y. The opposite of positive 30 is negative 30. So I'm going to bring down the negative 1, but I'm going to ignore it in terms of my factoring. I'm going to now factor what's left, which is y squared plus y minus 30. So I need to have my factors of negative 30, which are going to be 1 and 30, 2 and 15, 3 and 10, 5 and 6. One of them needs to have a negative, and because I'm shooting for a positive y, I'm not looking at the original problem anymore. I'm not looking at this negative 1. Trying to factor y squared plus y minus 30. I'm trying to get a positive y, and in order to get a positive y, the bigger number needs to be positive, the smaller number needs to be negative. So again, I'm kind of not looking at that anymore, and I'm not looking at that either. I'm just looking at y squared plus y minus 30 and trying to break it down to 2 parentheses. So I look at the minus 30, write down its factors, the right set that I need. So I can go minus 1 or plus 30, minus 2 plus 15, minus 3 plus 10, minus 5 plus 6. And when I go to combine those, I'm trying to get that y, which is a 1y. This is the pair that would give me the 1y. So for this, I'm going to break this down into y minus 5 and y plus 6. I claim that this is the answer, and you have some flexibility in terms of whether or not you put the 1 with the negative sign. I kind of like the 1 with the negative sign, but it's optional. Let me show you how to check this. It's a little tricky to check. It's actually a lot tricky to check. You don't have to check it, but to check it, you would do this. So the original problem was negative y squared minus y plus 30. I need to get that when I check it, and I need to go and multiply this out. First thing I'm going to do is work from left to right. I'm going to multiply negative 1 times y and negative 1 times negative 5. Put the result in the first parentheses. Negative 1 times y is negative 1y. Negative 1 times negative 5 is positive 5. I don't multiply the negative 1 into both parentheses. I'm done with the negative 1 now because it's incorporated into the first parentheses. Now I'm going to FOIL. My firsts are going to be negative 1y times y, which is negative 1y squared. My outers are negative 1y times 6, which is minus 6y. My inners are 5 times y, which is plus 5y. My lasts are 5 times 6, which is plus 30. This comes out to be negative 1y squared minus 1y plus 30. I don't have to write either of the ones, but I could. But if I didn't write the ones, I'd have a negative y squared minus y plus 30, which is exactly the original problem, so I know my answer is correct. So every problem I do between 59 and 74, there's either going to be a negative sign in front of this first term, or a common factor that I need to factor out. and then after I factor out a negative 1 or after I factor out the common factor, I'll factor what's left in the parentheses, but I'll keep that common factor in my answer. 62 is a lot like 61, so the first thing I'm going to do is factor out a negative 1. My factoring, I don't really factor so well when there's a negative in front of the first term, so I'm going to factor out a negative 1. When I factor out a negative 1, I put the opposite. The opposite of negative b squared is positive b squared. The opposite of positive 14b is negative 14b. The opposite of negative 33 is positive 33. So I'm going to ignore the original problem. I'm going to ignore the negative 1, and I'm going to attempt to break this into two parentheses, and I'm going to punt out the factors of 33, and I need a negative in them, so they're going to be negative 1 times negative 33, or negative 3 times negative 11, which would make my lasts either negative 1 and negative 33, or negative 3 and negative 11. The top pair, when I combine them, would give me a negative 34. The bottom pair, when I combine them, would give me a negative 14. That's the pair I need. So this b squared minus 14b plus 33 will break into b minus 3 and b minus 11. But I can't forget that common factor of a negative 1, so I'm going to bring it down. This would be how I'd write my answer. But you could also just write a negative without the 1. These are both correct answers. And you could actually write the b minus 11 parentheses first and the b minus 3 parentheses second, and still would be correct too. 64 and 66, there's a number in front of the squared term, but it's a common factor. The first step in every problem in the last group of problems is to look for a common factor and factor it out, or if the first term is negative, factor out a negative 1. Here there's a common factor of a 6. I'm going to factor out a 6. When I factor a 6 out from here, I'm left with a y squared. When I factor out a 6 from there, I'm left with a plus 5y. When I factor out a 6 from there, I'm left with a plus 4. That 6 is going to be part of my answer, but it's not going to be incorporated in the rest. So I'm going to ignore the original problem for now, and I'm going to ignore the y squared plus. So I'm just going to factor that. And that I can do pretty quickly because my lasts have to multiply to be 4. They can be 1 times 4 or 2 times 2, which means they could be a 1 plus 4 or a 2 plus 2. A 1 plus 4 would be a 5, a 2 plus 2 would be a 4. I need to get this pair, which is the 2 and 2. So I'm going to make this y plus 2 and y plus 2. This is an okay answer. This is also a good answer. Both of these are the answers. And again, if you have the desire and you want to check, it's not terribly hard to check, but it takes a while. So to check, I'll probably check that version. So if I wanted to check, I should be able to take the answer that I have and multiply it out. First thing I would do is multiply 6 into the parentheses that it's next to. I'll go 6 times y, 6 times 2. 6 times y is 6y. 6 times 2 is 12. Now I'm going to FOIL. First, 6y times y is 6y squared. Outers, 6y times 2 is plus 12y. Inners, 12 times y is plus 12y. Lasts, 12 times 2 is plus 24. And I have a mistake. Oh, good. So look what happened. I get 6y squared plus 24y plus 24. That doesn't equal 6y squared plus 30y plus 24. Hopefully, when you were watching the video, you were banging your head because I was a moron, because I didn't pick the right lasts. My goal was to get a 5y. Well, I didn't get a 5y. I messed up, and both of these are wrong. So let me fix what I just did, and I'll recheck it. That's the good thing about checking. When you make a mistake, you find your mistake. I should have made a 1 and a 4. I should have brought this 6 down and made one parentheses with a y plus 1, another parentheses with a y plus 4. That's the answer. Let me check that one. So it's not so bad when I make mistakes. When I catch them, it's actually kind of good. So if I wanted to check this, the first thing I'd do is I'd go 6 times y and 6 times 1 and get 6y plus 6. And I'll leave the second parentheses y plus 4. And now I'll FOIL. Firsts are 6y times y, which is 6y squared. Outers are 6y times 4, which is plus 24y. Inners are 6 times y, which is plus 6y. Lasts are 6 times 4, which is plus 24. Now I'm going to get the 30y. So there's 6y squared plus 30y plus 24. Hopefully this whole lecture isn't littered with errors. I haven't been sleeping perfect lately, and I'm on summer vacation. I kind of like to sleep. So last night I said, I'll just take some Benadryl. Benadryl just makes me sleep amazingly well, but I can't wake up real well when I take Benadryl. So this morning I knew I wanted to come here and do a lecture. I went and got a big old thing of Pepsi and drank it down, and so I have, I don't know, kind of on a caffeine high, I guess you could say right now, and maybe that's showing in my lecture. Hopefully it isn't, but could very well be. 66, there's a common factor of 4 I need to factor out first. When I factor out a 4, I'm left with an x squared plus 10x and a minus 11. And that 4 isn't going to impact my 2 parentheses factoring, but it's going to be around. So I'm going to ignore the original problem for a while. I'm going to ignore this 4 for a while. I'm going to factor x squared plus 10x minus 11. So my lasts have to be multiplied to be minus 11. They could be minus 1 and 11, or they could be 1 and minus 11. Because I was going for a positive 10, I knew this had to be the pair, which means I need to simplify negative 1 plus 11, which is positive 10, 1 minus 11, which is negative 10. The pair I need are this pair. When I factor that, I'm going to go x minus 1 and x plus 11, and my answer is going to have that 4 in it. So that would be a good answer, or you could write 4 times x plus 11 times x minus 1. You can completely check that if you want to. I know the video is getting long, so I'm going to skip the checking on this and just try to get to the end of this section before my video runs out. On 68, there's a common factor of a y that I need to factor out. So I'm going to factor out a y, take one y away from each piece. This is going to leave me with 2 y's, a minus 5y, and just a plus 6. Now I'm going to try to factor what's left, ignoring the rest. And in that parentheses, my lasts need to multiply to 6, but they also have to have a negative. So my choice would be negative 1 and negative 6, or negative 2 and negative 3. Negative 1 minus 6 gives me a minus 7, and negative 2 minus 3 gives me the minus 5. So I need the bottom one. So now I'm going to break this into 2 parentheses, one parenthesis being a y minus 2, another parenthesis being a y minus 3. And I'm going to bring down that common factor of y. I claim that's my answer. Let me check maybe one last one just to show you that I can check this. If I wanted to check this, the first thing I do is get the y into this parentheses by going y times y, which is a y squared, and y times minus 2 is minus 2y. I'm done with the y. Now I'm going to go into my foiling. Firsts are y squared times y, which is a y cubed. Outers are y squared times minus 3, which is a minus 3y squared. Inners are minus 2y times y, which is minus 2y squared. Lasts are minus 2y times minus 3, which is a plus 6y. These combine because they have the same letters but the same exponents. The numbers are both negative, so I'm going to add them and keep them negative. So you get y cubed minus 5y squared plus 6y, and y cubed minus 5y squared plus 6y is the original problem, so I know I've factored perfectly. On 70, there's a common factor of a 2, but the first term is negative. I need to factor out a negative to make that first term positive. So I'm going to factor out, well, actually more than a 2. I factor out a negative because the first term is negative. I factor out a 2 because every number is divisible by 2. I factor out a y because each term has a y. So my first step is I'm going to pull out the common factor of minus 2y. To figure out what's left, I'd go minus 2y cubed over minus 2y. The minus 2's cancel, and I had 3 y's. I took 1 y away. I'm left with 2 y's. If I did the same with the minus 10, minus 10y squared over minus 2y. Minus 10 over minus 2 is positive 5. I had 2 y's. I took 1 y away. I'm left with 1 y. And the last, 48y over minus 2y. 48 divided by negative 2 is minus 24, and I took its y away. So that's factoring out the common factor. Now I'm going to ignore the original problem. I'm going to ignore the common factor, and I'm going to factor y squared plus 5y minus 24 into 2 parentheses. I know my first are a couple of y's. Now I need to find the factors of 24. So they're 1 and 24, 2 and 12, 3 and 8, and 4 and 6. I need to get a positive. In order to get a positive, the negative has to go with the smaller number. If you put the negative with the bigger number, you wouldn't get a negative. You'd get a positive. You wouldn't get a positive. And negative 1 plus 24 gives me a positive 23. That's no good. Negative 2 plus 12 gives me a positive 10. That's no good. Negative 3 plus 8 gives me the 5. That's good. I won't even go to the next one. I'm going to put a minus 3 and a plus 8 in. I can't forget my common factor. It needs to be part of my answer. So I'm going to insert it now and call this my answer. Getting close to the end, I believe. 74 is the end, so we just have a couple problems left. 72 and 74 aren't written so well. Generally, I need to see the highest power of the letter first before I factor. So both 72 and 74 need some rewriting. I'm going to rewrite 72 with the 2y squared first, the 10y second, the minus 28 last. And when I do the rewriting, the 10y now needs a sign in front of it, and it doesn't have a negative. It doesn't deserve a negative because it doesn't have a negative to start. So I need to rewrite it with the squared term first, then factor out my common factor of 2. When I factor out a 2, I get a y squared plus 5y minus 14. Now I'm going to ignore. I'm going to go to factor that and break down to 14. I can get 1 and 14 are 2 and 7. Because I'm trying to get a positive, the smaller of the numbers gets the negative. And negative 1 and 14 will give me a positive 13. Negative 2 and 7 will give me a positive 5. That's the pair I need. So when I 2 parentheses factor this, I'm going to y minus 2 and a y plus 7. I can't drop the common factor. I'm just going to include it in my answer. This would be an okay answer. Similarly, you could write 2 times y plus 7 times y minus 2. What I think is the last problem, and maybe there's something hidden there that I didn't see. This is the last problem. Just like 72, it needs to be written in a nice order. It's not that easy to factor unless the squared term is first. So I rewrote the problems in a nice standard order with descending powers. I'm going to factor out my common factor of a 3, which will leave me with a z squared plus 3z, and 54 divided by 3 is 18. So I'm going to get a minus 18. And now I'm going to ignore this and ignore that. Factor what's in the parentheses. So I need a minus 18. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. It's a minus 18, so I need a negative, and the negative has to go with the smaller because I'm trying to get a positive. Minus 1 and 18 is positive 17. Minus 2 and 9 is positive 7. Minus 3 and 6 is positive 3. this must be the pair I have, so this parenthesis is going to have a z minus 3, or this factoring is going to have a z minus 3 and a z plus 6. Need to keep that common factor in my answer, so this would be an okay answer, or you can write 3 times z plus 6 times z minus 3, and that would be perfectly just as good. Alright, so a lot going on in this section. The next section's going to feel a lot the same. It's going to start off doing grouping, and it's going to end off doing a strategy that's similar to this strategy. It's just a little more involved because the problems in the next section will have numbers in front of the first term that you can't factor out by using a common factor. And that'll be a little bit harder, but if you've got this basic factoring down, then the next section won't be impossible. Actually, it would turn out to be easy at some point. But it'll be easy to confuse the strategies we learn in this section compared to the next section. So really, stay focused. Make sure you have this section completely understood before you move on to the next section.